In this video, we're going to do some extra examples with annuities. So let's begin. So suppose I want to have $300,000 in 30 years in an account that has 6.2% interest compounded quarterly. How much should my quarterly payments be? So I'm going to be depositing some amount each quarter. So I'm making payments. Okay, this is what tells you that you're dealing with an annuity. Okay, so we want, let's just switch colors here. Okay, so we want the payment value, and we know, so it's going to be in 30 years, so T is going to be 30. The R is 6.2%, so 0.062 is the R value, and it's compounded quarterly, so the M value is 4. And then the 300,000 is the amount we want to save up to. So because we're making deposits to save an amount, this is a future value annuity. And we know that the future value of it in 30 years should be 300,000. So the first thing we want to do probably is compute I, which is R over M. So 0.062 over 4, which is going to be 0.0155. And N, which is M times T, so that's going to be 4 times 30, or 120. Then we have a future value, so we use the formula for the future value. So future value is the payment times 1 plus I, to the power n minus 1 over I. So plugging everything in that we know, we're going to have 300,000 equals our payment value times 1 plus I is going to be 1.0155 to the power 120 minus 1 over 0.0155. So if we solve for PMT, the payment, it's going to be the 300,000 divided by this number. Oops, I missed a 0 here. Okay, and if you compute that, so I did do a bit of rounding, but I think that I didn't actually. Okay, but just to give you a step in between, it's going to be dividing by something approximately that. And you should get $871.97. Okay, so this should be our quarterly payment. So if we pay $871.97 every quarter, in 30 years' time, we will have saved up $300,000. Okay, let's try another one. So suppose I invest $20,000 now into an account paying 3% interest compounded monthly. So I'm going to start writing this information down. Okay, so my interest rate is 0.03 and it's compounded monthly, so I know my M is 12, and I'm going to leave it for 15 years. And this seems, we're not making payments, we're doing a lump sum now. Okay, so that's a P. Okay, so this first part is going to be a compound interest. Okay, so let's just have an idea here. Okay, so then after that time, so this is 15 years. So all this time we just have a compound interest account. Okay, with that information. Okay, now once the 15 years is over, what we want to do is withdraw a monthly stipend for 20 years. And the account is the same. Okay, and we're taking out a payment, so we want a payment value. And we know that the R is still 0.03 and the M is still 12 because we're taking each month a payment. Now we want to, because we're removing, so we're going to save up a bunch of money and then we're going to remove from it each month. Okay, this is going to be a present value problem. Okay, but we don't know the present value. So that's the amount we have at the beginning when we start to take out money. So the present value is actually going to be the A from the first part. Okay, so what we managed to save, that's what we're going to start with. So we want to begin by computing A. Okay, so let's use the compound interest. So A is P times 1 plus I to the N for the first 15 years. Okay, so we're going to find A. So it's going to be 20,000 times 1 plus 0.03 over 12 to the power 12 times 15. Okay, so this is 20,000 times 1.0025 to the power 180. Okay, now if you compute that, you're going to get $31,348.63. Okay, so that's our A value. So after the first 15 years, we've managed to save $31,348. Okay, so now that is going to become our PV. Okay, so then when we're doing, let's just do a different color here, maybe a dark blue. So when we're doing the PV, we want to find the payment. So PV is the payment times 1 minus 1 plus I to the negative N over I. Okay, so this is going to be $31,348.63 equals the payment times 1 minus, so I was 0.0025. So this is going to be 1.0025, and then the power is going to be, just make this a bit smaller here, power is going to be negative 12 times 20, okay, over the I value. Okay, so then if we compute that, the PMT value is going to be 31,348.63 divided by, okay, this whole part here. Now if you compute this and round, you should get 180.311, okay, which is going to give you, and I meant, again, you shouldn't really round, I'm just giving you sort of an intermediate step here, but you should get $173.86. Okay, so what that means is we will be able to withdraw $173.86 each month for 20 years, 15 years from now. So after we save up we use our 20,000 to save up some amount. Okay, so this is the amount we're going to be able to withdraw. So let's try one more. Okay, so I plan to use an ordinary annuity that earns 6.5% interest compounded annually, and I want to make equal annual deposits into this account for 25 years. Okay, I don't know what those deposits are. And then after that, I want to make 20 equal annual withdrawals of 25,000, okay, to get me to 0. So what's going on here, okay, so this is now, and then we're going to do something for 25 years, okay, and then 20 years later, So 20 years after, we're going to do something else. So in the first part, our R is 0.065. We're compounding annually, so our M is 1. Okay, we want to make payments, but we don't know what they are. And here we're saving up, so it's going to be a future value problem, but we don't know what the future value is either. Okay, and I missed T is 25 here. Okay, now on the next side, for the 20 years after, okay, we have T is 20 now. The R is the same. The M is also the same. Here, I know the PMT value is 25,000. And the only thing I'm missing is the present value. Okay, so what I want to know first is how much have I saved here? Okay, by this time. This is when the future value of the first part equals the present value of the second part. So, because we have enough information to find the present value, we're going to find the present value first. PV, let's say, of the second part. Okay, so PV is going to be our payment, so 25,000 times 1 minus 1.065 to the negative t, negative m times t, over our I, which is the same as r here because m is 1. And if you compute that, you should get 275,462.68 cents. Okay, so that's our present value. Now, for the first part, we're going to use the future value to equal this present value. So if we want to have enough money to take out these payments for 20 years, this is how much money we need to have saved up. So that's our present value. It needs to be the amount that we save up in this first part. Okay, so we're going to set those to be equal and then solve for the payment. Okay, so that's what's going on here. So our future value should equal our payment value times 1.065 to the power 25 minus 1 over 0.065. Okay, so solving for that. Okay, so I divide by this whole thing. Okay, in order to do stuff like this, you need to get a little bit calculator savvy so that you make sure that you do things in the right order. Okay, if you solve this, you're going to get $4,677.74. Okay, so this is what we must deposit each year for 25 years in order to be able to withdraw $25,000 each year for 20 years after. Okay, now how much interest did we earn during this whole 45-year process? So this is a little bit tricky, but if you think about it, it's not too hard. So the interest is going to be, because we started at 0 and we end at 0. So what it's going to be is the amount of money that we take out, okay, minus the amount of money that we put in, right? Because the amount that we take out is going to be more than what we put in, and the amount that it's more is the interest that it earned throughout this process. So how much did we take out? Well, we took out $25,000 once a year for 20 years. So 25,000 times 20, and what we put in was 4,677.74 cents 25 times. So if you compute that, the interest that you earned over this whole 45-year process is $383,056.50. Okay, so that may seem like a lot, okay, but the whole time in this first interval here, your money is getting interest, and the interest is getting bigger and bigger and bigger. Now, when you start taking money out, the interest doesn't stop. So you have this much money in there at this time, right? So you're getting quite a bit of interest. The interest doesn't just stop once you start removing money. It just starts decreasing slowly. Okay, so you're getting interest over this entire period. So you end up getting accruing quite a lot of interest. In fact, $383,000 worth.